Welcome back for video 4 in our video series where we're making an FPS inside of Unity. So I took a little bit of time and made some terrain here for us to kind of have some things to interact with. Set a skybox, set some water, but more importantly, I want to look at interactable objects. I'm not really the greatest level designer on the planet. I specialize a little bit more in coding. And so we're going to take a little look at how to make things interactable, like being able to push the E key to open doors, turn off the fires, and then also setting up some simple animations where we can, inside of Unity, build positional animation for objects, which will then, tie with our ability to press E to interact. So that's what we're going to do in this video. Already kind of assuming that we have our world built or partially built. So let's jump into that. All right, I'm going to scoot my player up closer to where the things are. Now, something that may save you a little bit of trouble, if you're using the WASD controls to move the camera, if you hold down Shift, the camera runs. So that's actually kind of a nice feature to move around quickly. Additionally, you might be running into the issue of the dynamic clipping being a problem. And that's going to rear its ugly head, especially when we're trying to look at something up close, because these things are so big. It wants to try to clip these. And yeah, as you can see, there's no way I'm going to actually get into good detail there. So if you go to the camera up here, you might want to turn off dynamic clipping. That will let us zoom in really close to objects without it accidentally clipping them or calling them from the camera. Okay, so we have a door. Hopefully you have some kind of door, something that the player can use, even if it's just a simple cube. And then be careful if you insert cubes in random spots. So even if you have a random cube stretched up to be a little bit taller, so that we can treat this like a door. And that's what we're going to take a look at. So we want to really start by kind of setting up an interface for the player to be able to use things. So let's start creating a new folder for all of that stuff for objects that we can interact with. So I'm going to create an object or a folder here called objects. So this is the scripts objects folder. This is for things, scripts relating to things in the world. Now, because everything is going to have a different profile when we interact with it, this is a really great use for some form of polymorphic behavior. So either inheritance or, in the case that we're going to use here, interfaces. And because they're all going to have different scripts, but we could at least code it to interact with the interface, and it will make adding new objects a breeze. So we're going to channel some comp.sci1 here and create a new script that we're going to turn into an interface. Now, the naming convention in C# is to call interfaces with a leading I. So this is going to be called iActivate, just kind of funny because it's something that can activate. So it's like the script telling you that I activate, but it stands for interface activate. So now what's kind of weird here is we don't want to inherit from mono behavior. We're not technically a Unity script. So we only want to just be a public interface called iActivate. And we're going to take out the Unity methods because since we're no longer a mono behavior, these start and update have no meaning anymore. So we're just a regular C# class file. The methods that I want to guarantee the existence of, and the autocomplete AI is already kind of figuring this out, I want to have an activate method. Now everything will have a different activate. If we activate the fires, that has different behavior than the doors, which will have different behavior than the mine carts. But we want to guarantee things that we can interact with have an activate method. Remember, this is an interface, so these are abstract methods, meaning they don't have any code. So that method's, we're going to trigger that. We don't need a deactivate method. I wanted some kind of get name. We'll just use it called get name or action name. No, get name looks good. And this should be a type string. This is so that if the player is looking at an activatable, once we start interacting with a user, like putting a HUD on the game, some kind of display text, it could say like open door. So the player gets this visual feedback that they're looking at an interactable object. So it's kind of a to-do thing, but... And then we need one more that's a Boolean called ready. And the purpose of this method is to tell the player if this object is ready, because when we open a door, as the door is playing its open animation, we don't want to allow the player to keep on mashing use. And so even if the door is halfway open, it will attempt to open again. And if we don't set up a ready, it will really allow the player to break a lot of the world. So and so these are the methods that our interface are going to guarantee. And activate is by far the most important, but ready and get name will help facilitate this process. So we're going to hit save to save our interface. And then let's start by making a door. So I'm going to right click inside of here and create a new C# script. And just for naming convention's sakes, I'm going to call this activate_door. And that's just so that any of my scripts that deal with like activatables have this very distinct naming profile. I'm eventually going to have like an activate minecart, an activate fire, activate level transition. So we'll have a lot of these, but I just want an activate door right now. And to actually implement this, we do need to remember a little bit about how inheritance works with C#. I couldn't use an abstract class because mono behavior is already a class, and we can't inherit from two classes. So let's inherit from our iActivate interface just by putting a comma and listing it after the inheritance command. And you'll notice that because it's an interface, it's upset that we haven't implemented the methods that are guaranteed by this interface. Ooh, I spelled activate wrong. Let's go fix that before anything gets worse. Activate. No, that's right. Well, perhaps if you spell activate enough times, it starts looking weird. So we're going to go to show potential fixes, and we're going to implement the interfaces. So it adds these three methods here, and it has a little error exception that it throws. That's fine. We're going to replace that very quickly. So let's add a few things here. Oh, my cat is happy to work on interfaces too. I think she's not a huge fan of polymorphism though. So we need to create some messages. So we'll have public string activate message. This is the message that the player will see when this thing's about to be activated. So for a door, if a door is about to be activated, you activate a door by opening it. So this will say open door. So we'll have a deactivate message that says close door. So when the door is open, this is the message that we will display to the player's screen when they're looking at the item. So now we need a Boolean called isActivated. Now this could start true, that's why it's public. And we might actually want to put a tooltip on that. So for example, like a light might already be activated. Well, I know you don't like lights, Kitty. I think she's just mad my microphone is where she wants to sit. So like if a light is already on, we would want to set this to true just to help keep our logic a little bit consistent. And then we need a private variable called isReady. And this is whether or not the thing is currently interactable. So for example, when the door is opening, this is going to be set to false. So the trick here for the door, and we're going to do this programmatically. We'll look at setting up like an animation in Unity when we get to the minecarts. But let's kind of go through and program some of these methods here. So ready is really very simple. It's just going to return isReady so that the player's script, when we get around to writing that, will know if this can be interacted with or not. And then we also might want to record how this object is going to, like how much this object needs to move. So we're going to create a public vector3 called rotation amount. I guess it can initialize to vector0. But it being a public variable, we're going to edit that. And we'll put a tooltip on it too. So this is the finished angle that the object should rotate to. Like I said, we're going to define it inside the editor. And then we need an animation time. And this is how long does it take to complete this rotation. And that's going to influence the speed at which it animates. So I'm just adding some tooltips here for all of these. And these are the settings for our door. Oops. So that is our variables. Kind of a big collection of things. So we could hit save on this, but then we want to go through and actually start programming some of these. So we don't actually need update or start, interestingly enough. So none of those will be used in this. And actually, we do want to try to avoid using update because we don't want every interactable object trying to run commands every frame. We really only want this to do stuff if the player tells it to do stuff. Okay, so get name is going to be pretty, I guess the correct term is boilerplate. It's going to be a pretty generic setup here. So if the object is ready, then we are going to, well, then we have, depending on whether or not it's been activated yet. So if is activated is, we'll do false. The object is off. So for example, the door is closed. And this is what happens when you turn it on. So for example, open door. And then we have return our deactivate message. Otherwise, so outside of this, we could just then do return object is busy. So if you're looking at a door that's currently opening, at least you get some feedback that the door is currently busy. All right, so getName, not a very exciting method. We're probably not going to need to revisit that method or the ready method. So we can minimize those. Now the meat of the programming is going to happen inside of activate. So this is where we're going to put our logic for actually getting the door to behave. So if the door is ready to be interacted with, then we've just sent it a command to do something. So is ready will be set to false. So the door is, the door is about to do something, so you cannot use the door for a while. So don't let the player be able to use the door. If is activated is false, so basically the door is closed. So the door is off, which means that it's closed. We will need to go write another method here. So we'll call the opening method here. And then when that is finished, we'll set is activated to true. The door has been opened, so next time we come back and we try to use it, we'll close it. So elsing off of that, the door is on, which means it's open. All right, now for something kind of new. So essentially what we want to do is we want the door to rotate itself tiny amounts every frame. And the best way for the script to do that is a structure called a coroutine. So we're going to write a coroutine over here real fast. It's private because it doesn't need to be seen from outside the class. Now, the return type is kind of weird. The return type is an I enumerator, which is what is used for coroutines. The name of this method is going to be called rotate door. And then this is by how much and the time. Let's call this anim time. So this is going to be our method where we're going to actually animate the door. And so we can call it right here while we're thinking about it. Now we don't call it just by saying rotate door. We actually run the command called start coroutine. And then the coroutine that we're starting is the rotate door method. This is kind of a new way of thinking about it. What basically happens is this gets launched. It's almost like a multi-threading behavior. This gets launched off of the script and will run concurrently with the rest of the script. So this will continue to go through. So like instantaneously, it's going to run this and then jump down to is activated. But the coroutine will be called over the span of this time frame here. So until the coroutine is done, it will continually do things. And so we'll call it down here with a negative rotation. Now this works for these doors. If this ends up not working correctly, you might just need to specify a separate type of closing rotation amount. But in the case of a door, if you open a door 90 degrees, to close the door, you just rotate negative 90 degrees. So for a door, this is fine. All right, so we're gonna start with this is actually quaternion. So we're gonna grab our rotation, and then we're gonna calculate our rotation by using the Euler method. So it basically computes a rotation. It's the destination rotation, and you'll see what's about to happen with this. Transform dot Euler angles plus the amount. So this is really just saying, what is my goal rotation? This is my starting rotation. What is my goal? And so those are, you know, that's the desired completed rotation. Now we actually want to perform the rotation. This is actually done in a loop because of the way that an enumerator is going to work. So now what's kind of crazy, we are going to use a float as the iterator here. So we're going to float t equals 0, while t is less than 1, t plus equals time dot delta time divided by n time. So essentially anim time. Essentially what this loop is doing, it's creating a fraction of how much time has passed over the desired time, so that as that adds up, it will reach 1 when that amount of time has passed. This fraction would be 1 when the total sum of the numerator, the time dot delta time, would be equal to the animation time. So this is kind of a fraction of the time. It's a normalization from 0 to 1 of how much time has elapsed. So we're actually going to perform the rotation. So you'll see that it actually wants to autocomplete with a lerp. And we could use a lerp, but we'll do a spherical lerp, which is known as a slurp. It's kind of a silly name, and you can see it has auto-completed correctly everything we would need for that. Then the coroutine part This pauses this loop until the next frame. So yield return null will pause this until next frame. Then the coroutine remembers to pick up from where it left off. Then it will eventually finish. This will only execute once because the coroutine will stop getting called when we get out of this loop. And so when we're finished, we can set is ready back to true. And so this is kind of a fancy way to do a rotation using only code. We'll look at setting up an animation in a second, but this will open the door. Well, I guess we need to program the player side of this. All right, so we're going to jump over to the FPS controller, which is our player stuff. And we're going to want to set up the ability for the player to interact with things. So I'm not sure what that would be under, possibly world settings. We can make a new one. Header interaction. And we're going to make a variable here called public float interact distance. This is going to be the distance away from things that the player can interact with them. And we're going to set it to 3. It might need to be tweaked a little bit. All right, so we got our interact distance. Now we're going to set up this method. So we are going to use a raycast. Now a raycast is basically like a laser pointer coming from your camera. So it's going to be like a laser sensor that flies in a straight line directly at whatever you're looking at. So this method is called interaction. We will call it from update right after we've done the other ones. And then we're going to minimize look, and I'm going to minimize move just so I don't have as much clutter on my screen. So this interaction method, this is where we're going to handle our use in raycast. So we're going to construct a raycast. So there's a data type called raycast hit, which is going to be the thing that is, it will return essentially the game object that's being hit. I think it returns the collider and some information about like where on the collider it got hit. But ultimately for our purposes, this is the thing that is hit by the raycast. Then we will want to actually build the ray. And so this is going to come from the camera. So that's why I'm using playerhead.transform.position rather than just the regular transform.position, because that would basically be the center of the player's body, the chest, or the feet, depending on where the pivot is. And we want it to come out the forward vector. So whichever way the player is facing is going to be the direction of this raycast. Now, if you wanted to lower it a little bit, if the player's head is too high and you're worried it might like kind of clip into things, you can lower it down by like subtracting out like a vector 3 here. And so that would lower it 0.1 units from the player. So essentially, if we go look at the player, because the issue with this, as you can see, the camera is kind of on the top of the player, so the ray cast might need to be lowered. And actually, like, just looking at this, I am going to lower the camera down so that the camera is on the very top of my collider, so that if your head bumps into something, then it bumps into something. All right, so let's get back to that script. So we've calculated the ray. Now, I want to use a layer mask because I want it to ignore the player. Right now, everything is on the default layer, but we're going to change that. So we're going to need to remember to move the player to a new layer. And then I have a Boolean here called did it hit, because when I make the ray cast, physics.raycast, it will return true or false if it hit something. Now this is also a little bit of C# shenanigans. And we're returning two things actually. So we have a parameter that's allowed to be returned into, which is kind of new. That's what this out keyword means. So this parameter hit, that's actually currently null, is going to receive I would say a game object, but it receives a raycast hit. It receives whatever's getting hit by this raycast. So this variable will now have a value, and we're going to do something with it. And then did it hit is going to return true or false. And for the sake of testing, we could say if did it hit debug.log looking at, and then hit dot collider dot game object dot name. So that's going to get the game object that was associated. Ooh, his collider must not have been happy. It's going to get the game object that we're seeing. Now, because it's coming out of the camera, it might hit the player, and this is a good debug to see that. All right, so with this, we should be able to test it. So let's hit save. We don't have to attach any new scripts because this is already on the player, and it should inherit the settings that we set up there. So we can hit play, and if we look down here at the bottom, so we see a problem. If you look in the bottom left of the screen, you can see it says looking at player. So my raycast is hitting the player. You can see that it's hitting the doors. So as it looks around, it's hitting different things. But we don't want to be hitting the player because that's kind of problematic, because if you want to hit a low switch, well, you know, you're hitting the player, not the door. So we need to move the player to a different layer. So up here in the top right, there's a layer. Now we need to add a new one just for the player. So I'm going to put it on user layer 6, called player. Then much like a tag, you just have to go back to player, and then we can reassign it to here. Yes, I do want to change all the children to be on that collision layer. Now, that isn't going to affect anything, because if we take a look at the project settings, you can still see from the collision matrix here that player is still interacting with all of the other layers. If you needed it to ignore layers, you can just turn it off from here, but player will collide with the default, so it just allows me to exclude the player from the raycast. And so now when I go back to hit play, and I start looking down, you can see the player is no longer what's getting raycasted. It's passing the raycast through the player to hit the terrain. And so now, like, I can hit switches directly beneath me if I wanted to. So we're almost there. Now we've just got to set up the actual use action. So going back to the FPS controller, right after this little bit of debugging, which we could actually turn off now because we know that it's working, but I'm not going to delete it because it is useful code. It is useful to pull that back up and experiment with like raycast distances. So we need a new key. So input.gets button down use. It's going to be a new axis we're going to have to go define. I don't want to say like if they press the E key because I want to be able to have the keys user definable. So if did it hit? So if it found something, then we're going to attempt to see if it has the script on it. So we're going to get the activatable script. So we're going to actually get a reference to the interface. And this is where the polymorphic behavior comes in. I can spell activatable. So the thing that we hit, we're going to pull up the collider, pull up the game object that was attached to the collider, and then grab this script. But in reality, it's going to be a door script, not an iActivate script, which is okay, because if it actually had that script, then all we have to do is call activate. And so if it finds an iActivatable child script somewhere, then we run the activate method, and everything that implements this interface will have a different script. So doors, minecarts, fires, level exits will all have a different behavior for activate, but we know that it has an activate method. And we don't have to write anything new for any new objects. That's the beauty of using this polymorphic behavior. Now you could get fancy too and also have this like push things. Like if it was if it wasn't an activatable object, you could apply like a physics push, because technically did it hit will contain an object. We're only interested in activatable objects though, but you could expand this to interact with almost anything. So hit save, and the door should have been finished. So let's test the door. So oh wait, we didn't actually define the rotation or attach it to the door. And we also, as the error said, we didn't set up the use key. All right, so let's fix the use key. So that's going to be under edit, project settings, and that is an input thing. So let's add one new axis. So it's now 23, and it created a run. Well, I don't need that. I want to name this use. The use key is E. You can set it to whatever you want, but most games use E or F. And let's base it off of the jump key. So none of those things are checked. So we don't have any of those checked. So 1000.001, 1000, and nothing checked. All right, so we can close this. We now have a use key. So let's go attach our script to the doors. So you can click your door and take our activate door script and drag and drop it to the thing in the hierarchy. And you can see that we've got our text here. As far as the rotation we want, it's probably going to be a 90-degree rotation. We'll find out real fast if it doesn't work. And however long we want the door to open for, maybe I want 1.5. So I'm going to drag this to the other door. Now I know from experience in this specific case it is -90, and it'll have the same activation time. So one thing you'll notice, well, let's test this, and then we'll point this out in a second. So when we go up to the door, and we push E, the door opens. 40 minutes of work for a door to open. But what's great is, so now it goes back the way that, so it closes. Now, to be fair, it only opens in one direction, so it is going to open this way. And no matter what the player does, if I sit here mashing the E key, it only interacts when it's done with its thing. So I can't mess it up. And so that is our wonderful opening doors. You could trigger a sound effect on this if you wanted to. I'm probably not going to do that. But you could set up like a sound listener or a sound source. You can play a sound effect off of it. Some of my windows are failing to load there. That's fine. All right. So we got our door working. Now, the thing I did want to point out is this object is actually set up to pivot. Like the pivot of the object is actually like set up inside of the model editor. So this is like a Blender or like 3D Studio Max thing. This is not a Unity thing. So this model was already set up with a specific pivot. You could get fancy with, so like the problem with other objects if you wanted to do that. So like if I had a cube and I wanted to look at its pivot, its pivot is the center. So this gets a little bit, problematic with like how you would end up doing it. So you could probably create an empty parent on it and then play around with the cube's position within that parent. So, because notice how the cube is here. So like if you move it over there, you can kind of see that you can sort of rig up a pivot in some respects here. So that if I have a cube and I want this cube to simulate behavior like a door, then I would just put the script on the parent. That'll be interesting to see if the collider works. You might need a collider. So that would mean kind of got two. Whoop. Parent needs the collider. There it goes. So if you notice, it was rotating around that pivot. So actually, let me take the collider off the child. So now if I walk up to this and this was my door and press E, you can kind of see it opened like a door because I set up this kind of an empty parent, but the parent holds the script so that the effective pivot, the pivot point is the parent's location, but if you just shift the cube around on there, you're able to kind of mimic that. Other than that, it is kind of tricky to set up pivots. And we could also, the next video we'll look at using the Unity's animation. And so you could probably also set it up using the Unity animator as well. So we'd be able to kind of get around that. So we'll take a look at using the animator in the next video. So thank you for watching.